Here. Wow, I am so pleased to be speaking to this group again, to be invited here. Jim asked me a couple weeks ago if I would speak, and it wound up being a real twofer in that while I was procrastinating and getting my thoughts organized, I got the garage cleaned out. So, or mostly cleaned out anyway. I am Ron Barker, and I'm a retired optometrist from Mishawaka. Uh, and I guess I first got interested in planetary. We've got the Proverbs slide, the first slide. Yeah, we can move to that. Yeah, Proverbs. Proverbs, it turns out, is always good for a sermon. Uh, but this particular one I have found that I just love. There are a bunch of different versions of it, but one of them is he who spouts off before listening to the facts is a fool. And sometimes when I speak about climate change, there are some people in the audience who would spout off absolutely. I don't know whether there are any people here who have doubts about this whole business of climate science, but I got interested personally in planetary issues when I was about 10 years old. We had a weekly reader, and the headline article was that there were 2.5 billion people on the planet. And I had to ask Miss Fredericks how to write that number, which I think she struggled with a bit too. But between all those zeros and the launch of Sputnik later that month, I was hooked. I really got interested right then. I've been giving talks about climate science. My first degree was in political science, okay? And I took science courses then as electives just because I loved them. And then later decided that I would examine eyes for a living because it was better than being a lawyer. But in any case, I started talking about climate science when George W. Bush was elected. That night, I can remember thinking, uh-oh, nobody's going to be speaking about the environment for a while, and maybe I should. And so, let me tell you, even then, I knew global warming is actually a thing. It's human caused and it's very important. When a planet heats up, climates everywhere shift and they alter, and that's how global warming and climate change are linked. They're the same thing, just opposite sides of the same coin. Now, I think we can go on another slide. Yeah, we're out there in space all by ourselves. The earliest observation that certain gases retained heat, radiant heat, were published in 1856. There was a woman named Lucille Foote, and she didn't get credit for it because she was a woman. 3 years later, John Tyndall got the credit. And then in 1902, a Swedish Nobelist coined the phrase global warming. And in fact, you can find an entire article about global warming in the 1912 issue of Popular Mechanics. It was a very good article. I sat down and read it, and the physics are all there. They knew early on that this was a possibility, but in the early part of the 20th century, it really didn't. It really wasn't much to worry about. It was just something that theoretically they understood could happen. Of course, there were interruptions, the 2 world wars. There were just a lot of things going on in the first half of the 20th century. And the real work didn't get started until about 1957, when Sputnik was launched, and when I was wearing my Davy Crockett coonskin cap. A few scientists had started exploring how the atmosphere was composed. And let's see if I've got the right slide. I think I do. I'm going to have to coordinate with Beth here, and I'm unused to that. How the atmosphere is composed, how it manages the planet's temperature, and what evidence there might be of past climates. The scientists knew that they were onto something critically important, but science is slow, it turns out. It takes generations of superbly trained people to assemble giant findings like, how the Earth works. You need to realize that Landsat 1, the very first satellite that was designed and launched to look down at the Earth to do research, was launched only 50 years ago last month, August 50 years ago. Since then, Earth science has become one of the most consuming scientific endeavors ever attempted by mankind. It's just colossal in both its scope and its implications. Go ahead and change the slide. Whoop, well, maybe 2 slides, but the story I want to tell begins with these ice cores. Actually, go back to, that one. Simple ice cores. In the polar regions, it's always been cold enough that snowfalls never melt. They just pile up one after the other and compress into sheets of ice that can be as much as 2 miles thick. They know, and actually they've found ice by going sideways. They've found ice that is older than the 2-mile thick stuff. But if the ice is left undisturbed, you can go on to the next slide. The oldest layers are on the bottom, and the youngest ones are on top, so they can be counted and they can be read almost like tree rings. Now, this is a simple example of, say, I don't know whether this shows. It doesn't. Oh well. I don't have a pointer. These rings right here. That's a very simple example of what's going on in tree rings. When you get down to 2 miles, the ice gets so compressed that it takes electrical readings, just all sorts of science, microscopic readings to parse those layers one apart from the other. I'm sorry, to parse those layers one apart from the other. But in any event, the rings, the layers, these cores of ice, can be read and correlated directly with other lines of evidence, like sediments cored from ocean floors, ocean sediments, and fossil records, all sorts of records that simply confirm and suggest one way or another, proxies, for what's going on and showing best perhaps in the ice cores. It's amazing though what they've found in these ice. Change the slide. The ice contains layers of bubbles. They can slice it, and it contains layers of bubbles of the actual atmosphere that snow fell in. So it doesn't matter if it's 10,000 years old. You can draw out that particular slice and analyze it and find out how much CO2 was in the air at the time. You can also tell from the oxygen isotopes, roughly you can construct a temperature model. Go ahead and change the slide one more time. What we found is that there have been more than 50 cores that have been drawn from all over the world, from Vostok, Russia, and Antarctica, and up in the Arctic and Greenland. And all these cores tell the same story. 800,000 years of solid data showing that carbon dioxide and concentrations and ambient temperature are tightly linked. Go ahead to the next slide. Right there, you've got carbon dioxide in blue going up and down over an 800,000 year period. And the reconstruction of temperatures over that same time, you can see that horse and carriage are pretty tightly bound together. From that and the Mariner and Viking missions out to Venus and Mars and Mercury and generally elsewhere, we've found that we know that as few molecules of carbon dioxide as are in the atmosphere. It's about 4 molecules in every 2,500 in the room. And for reference, your last breath, you probably took in 500,000 molecules. If it were all, interestingly, if it were all evenly distributed, some of those molecules were the same molecules breathed by Jesus. Makes you think when you're in church. But in any event, this few number of carbon dioxide molecules are what run things as far as temperature is concerned. Let's see here. Go ahead and change the slide. Yeah. I think the whole point is that when CO2 is up, temperature goes up, temperature gets warmer, and when it's down, temperature gets colder. There is a natural carbon cycle, okay? And that cycle occurs only over hundreds of thousands of years. You can see here 800,000 years back. I hope you can read this. Maybe not. 800,000 years of data, 800, 700, 6, 5, 4, 3, 2, 1. The most recent information is on the right-hand side. Don't worry about that line going up right now. What I'm trying to show you here is simply a less cluttered map of the data that shows that over hundreds of thousands of year periods, the carbon dioxide naturally goes up and down with orbital changes. So that is the natural variation, and oftentimes people who disagree with the idea of climate change say, there have always been changes, the Earth has always changed and it always will, and I'm not going to pay any attention to this. Well, like I say, there are natural changes, but they don't occur on human timescales. Most people I've found have real difficulty grasping big numbers. They can scarcely imagine millions, not even hundreds of thousands. And now you can go ahead and change. Thanks to Disney's cartoons, we all have some sense that at some point there was an ice age, right? I think everybody here has probably seen the mammoth and is that true? Does everybody know about the mammoth and the little obsessed squirrel? Okay. Yeah, there was an ice age. And so let's zoom in and see when that last occurred. Go ahead and change the slide. Now this is a complicated slide, unfortunately. I had to lift it from a YouTube video from National Aeronautics and Atmospheric Administration. But what it shows is the last 25, 30,000 years of that long 800,000 year graph. Now, 25,000 years ago, and I'll point to it, I'll talk loud if I can. 25,000 years ago was the low point right there, and we had about 185 parts per million of carbon. And that was a natural change. It was about that point, was that point. Right then, it was so cold that Bering Strait was only about a mile away. That's hard to believe. We were at the trailing edge. Thank you. We were at the trailing edge of the ice sheet that had come down in the previous 25 to 50,000 years. But it was also right then when the Earth, the orbital mechanics of the Earth, the wobble of the Earth, the path around the sun, the tilt of the axis of the Earth, a number of different things, caused again us to begin a gradual warming. Okay, and so incidentally, 25,000 years ago was also when the very first people came, we believe, from the Bering Land Bridge and came paddling down the west side of the ice to begin to settle in North America. That may be, unless there was something going on the East Coast that we don't yet have evidence of, people spread. Homo sapiens, in fact, they were Ice Age people, but if you gave them a haircut and put a shirt on them, they could sit in church and we'd say hi. So, but these folks came down and they were struggling against a very cold world. And gradually it got warmer until that little peak, you can see it going straight up, okay? And I don't know whether I can point to it, but it's the little peak at 10,000 years. And at 10,000 years, the climate had become warm enough that civilization was kind of able to settle in. People were able, at that point, there were large numbers of people in America, or reasonable numbers. And worldwide, in fact, they were able to start farming and go into specialized administration, things like that, and build civilizations. So, you know, it was pleasant, or at least it was reasonable. After it got out of that 185 parts per million, remember there's a link between carbon and temperature. And even though it looks like it happened pretty fast on a graph like this, the actual warming occurred over about 20,000 years. So we got started, farming and civilization. And go ahead, I think, make another change. One more slide, please. Let's make it. Okay. Let's skip that slide. Okay. Now, this point on the graph happens to mark the beginning of the Christian era. This is a measurement of CO2 in the atmosphere. And it shows that at year one, when Christ was born, okay, all the way through to about 1850, things were quite stable. There was carbon there, and the temperature was reasonable. And in fact, this is where the slides got goofed up. And so I have a little bit of difficulty with it. But based on the stability, humanity thrived. And during that 2,000-year period, we built our civilization with all of its infrastructure and all of its interdependencies. We grew from a few 100 million people to 8 billion people, and we built cities on shorelines that we thought were reasonably stable. We designed agricultural systems that assumed the presence of water and settled down with reasonable assumptions that our weather was reliable in some sense and that we understood our world. But all that activity, all that growth required colossal amounts of energy. And so I don't know whether we can return, especially as the modern world developed after World War II. There was this enormous use of carbon. We burnt coal in order to provide energy to do building. The energy that we used, though, was fossil fuels, coal, oil, gas. And the key word there is fossil. It means that it was the product of millions of years of plants soaking up energy from the sun and then dying, rotting, and being compressed into these remarkably dense chunks of old energy. I'll pass this around. Please get it back to me. It belongs to the geology department at IU. This is a chunk of coal. A few of you, I imagine everybody here is old enough to have seen coal. My first job when I was 5 years old was carrying the coal ash. I would get a bucket and get a dime for carrying a bucket of coal. And that was before my parents moved. But this is a dense chunk of energy. That's the way you can think of coal. Now, starting about 1850, the chemical signature of our fossil fuel use began a sharp rise in the atmosphere. They can tell by looking at these molecules, by analyzing them, where they came from, whether they came from volcanoes or whether they came from plants. And believe me, it was all fossil energy. When I was 10, the atmosphere contained about 315 parts. Oh, back up. Yeah, when I was 10, the atmosphere contained about 315 parts per million of carbon. And it was cold enough that every winter I was able to skate for weeks on the flooded tennis courts of Mishawaka Park. Now think about that. We haven't had weather like that reliably in the last few years. As a matter of fact, we haven't had weather like that in my recent memory. But when I was in 8th grade, no problem. I got ice skates for Christmas, and I had a blast every year. But new research was showing this clear trend of rising temperatures in the northern hemisphere. Now go ahead, Beth, and take that next slide. There it is. And the temperatures were rising, and that was brought to public attention in 1998, basically 25 years ago. And it was very quickly and derisively attacked as the hockey stick. And there, at that point, the fossil fuel industry was beginning to realize that it was deeply threatened by any movement to move away from fossil fuel. And so they set up a misinformation campaign that was eventually very successful. But scientists were certain that those temperature trends were tracking carbon dioxide measurements that were also rising, and the scientists began to sound an alarm. Since the 1950s, humanity had burned a virtual explosion, an explosion of stored fossil energy that left its waste product, carbon dioxide gas, in the atmosphere. Now, most of the atmosphere is made up of oxygen molecules and nitrogen molecules. So O2, oxygen, that's two individual atoms of oxygen locked, I don't want to do this, locked together, and they don't have a whole lot of movement, okay? They just don't have a whole lot of possibility for movement. But if you take the two oxygens, and maybe this one will work, I don't know. If you take the two oxygens and attach them to a carbon molecule, they're free to move, and baby, they dance. Okay, they're up there absorbing heat and dancing like crazy. They've got a lot of room for molecular movement. They absorb heat, they work up a sweat, and that's about the simplest way that I can tell you that carbon dioxide manages to heat the world. Okay, go ahead and move on to the next slide. Yeah, and so that's the problem. Once carbon dioxide is up there in the atmosphere, it stays there, trapping heat for about 1,000 years. So for our purposes, CO2 accumulates and it stays there forever. It retains, that represents a band of carbon dioxide. It represents the atmosphere, actually. Okay, and instead of allowing a favorable balance of heat to leave the planet, the sun beats through, radiant heat bounces off the earth, and more of it is retained when those carbon atoms are up there bouncing around, or dancing around, I should say. We also know that there's a time lag between the arrival of a new molecule of CO2 and its effect on temperature. It takes a bit of time before the pot warms up when you turn on the heat. But that means that the climate changes that we are experiencing now are probably the result of fossil fuels. I think you can probably change. They're probably the result of fossil fuels that we burned 2 or 3 decades ago. So this time lag means that that what we're getting now is stuff that we heated our houses with in 1990 or so. The ominous predictions that were suggested by that early hockey stick and by the early talks that I gave has now been validated by scores of supercomputer models and also by regular measurements developed all over the world. Those predictions are forecasting an extremely challenging future unless we don't change our ways. That increasing blanket of CO2 continues to retain heat coming into the system, and things become less predictable and often hostile. Okay, that's the trouble. The additional heat causes water to evaporate more easily from the oceans. It sucks water, evaporates water more efficiently from the ground, leaving the ground dry. Go ahead, Beth. And that's Lake Oroville in 2011 when it was full out in California. The next one. Yeah, here we go. Okay, right now Lake Mead is down to about 20. Lake Mead, that's on the Colorado River, is down to about 25%. When you get hot, or when the world gets hot, what you get is more efficient evaporation into the atmosphere. And so there's less snowfall, there's less rain, rivers tend to run dry, and that is right now happening all over the world. The Yangtze River in China that provides water for 400 million people is running dry right now. I don't know exactly what's happening, but I know that it's running dry. The Rhine River in Europe, last time I looked at the Rhine River, I walked up to the edge of it and looked down, and it was one of the most forbidding flowing, bodies of flowing water that I'd ever seen. I looked at it and I thought, man, if you fell into that, you would be done for sure. And last month, the Rhine River was measured at almost that same point that I stood at 12 inches deep. You could walk it. So, heat waves, we wind up with rivers, we wind up with drought. Challenges to freshwater supplies. You're going to start hearing about towns like Cape Town, Africa, South Africa, that just recently came within about 30 days of running entirely dry. And I believe there are some communities in the United States right now that are coming real close to just having no water. Now that's what happened to the Anasazi natives. That's why they moved out of the Southwest a couple thousand years ago. It's also what happened to the Mayans. If we don't have water, we don't have civilization. It also means, go ahead and go on to the next slide. It also means that occasionally things, the polar vortex, which is ordinarily kept in place by temperature differentials between the Arctic and the mid latitudes, occasionally, if those temperature differences go out of whack, what you wind up with is polar vortexes that slip down and freeze our tushes. Okay, go ahead, the next slide, Beth. You can see what happened. This is in 2014 when the southern part of the globe was in its summer, and it was hot, very hot, in fact. And up north, we had a week and a half period where the polar vortex slipped down and froze us. Froze us so badly, incidentally, that I had to not give a talk. It was canceled, a talk on global warming, so I took a lot of grief about that. But in any case, the hot conditions and dry ground, I have to tell you that because there is so much water that's evaporated into the atmosphere, actually for every single degree that the planet rises, there's about 4 to 6% more water. And in fact, in the last 30 years, 35 years, there's more water in the atmosphere, significantly more than there was then. And it makes a difference in the way water falls. If you have too much water in the atmosphere, it means that the clouds are basically pregnant. They're waiting for the right conditions. And when the right conditions come along, it often comes in torrential rainfalls. Rainfalls that are just ruinous. Go ahead and take the next slide. This one is Houston in 2015. Houston in 2015. Houston got hit in 2015 and 2017 and got it, well, there 50 inches of rain fell in 24 hours. Now, 50 inches is this much. You can imagine what that would do to any city. And it's happening elsewhere too. It's happened in Kentucky. It's happened in Maryland. It's happened in Virginia. It is happening all over the United States and all over the world. Today, 1/3 of Pakistan is underwater, 1/3 of the country, and most of it's arable land. Now you can imagine what kind of troubles that creates. The hot conditions, go ahead to the next slide. The hot conditions are just perfect because when the ground dries out, the plants also dry out, and so you get wildfires. And if there was a period up to about 2015 where people were interested in climate science, and then there was a period where they weren't interested in climate science. But the fires in 2019 in Australia really woke up everybody. There were these, I think they call it the Black Summer in Australia. And of course, California also burned. And so did large sections of Washington and Oregon. And we continue to have those burns. It's just perfect for, go ahead, next slide. it makes things very, very difficult. This is Noblesville, Indiana, I think. Yeah, Farmington, Illinois. Just a picture of the ground. And you've all seen ground like this, I suspect, where it's simply dried out and you can't farm. That means that we have trouble with famine all over the world, when particularly the United States is a little bit less vulnerable because center pivot irrigation takes most of it, or irrigation systems. But in Africa, that's not the case. In Ukraine, that's not necessarily the case. So, you know, these heat waves are really bizarre. They dry out the ground, and you can get 120-degree heat waves in British Columbia. I think it was 2 years ago, 122 degrees in British Columbia. That same town, I can't tell you the name of it, but that same town burned down a week later, just burned to the ground. Heat combined also with humidity. I don't know, go ahead to the next slide. We'll skip that for a moment, just stay on it. But heat combined with humidity makes for what's called heat index, as you've all heard. I think the weather channels are normally saying, you know, watch out, tomorrow is a dangerous heat index. Well, heat indexes are at some point dangerous, labeled dangerous, and at other points beyond that, they're labeled extreme. An extreme heat index between 120 and about 140 becomes what's called unsurvivable, okay? At 140, you can't sweat, and the heat just basically cooks human beings. Now, unfortunately, around 2050, 28 years from now, much of the equatorial world, and in particular, the Middle East, is predicted to have such extreme conditions for potentially the entire summer season every year. Now, if you've got heat indexes that have suddenly gone up to 120 degrees, people don't have it. They either live in air conditioning or else they die. They certainly can't work outside. And that means that the Middle East is going to move out. It means that there's going to be migrations of people. They figure up to 500 million people are going to be looking for places to live that are away from the famine and have fresh water and away from the heat. So what that pretends is conflict. I mean, the Syrian migration started with a bit of a famine. The farmers moved into the cities, and the cities couldn't sustain them, and eventually they went to war, and 6 million people decided to move to Europe, and that occupied Europe's headlines like crazy. We are completely, you know, absorbed in our politics with the absorption of maybe 11 million people from South America or from Central America. Just 11 million. Can you imagine what 500 million people, deeply motivated to walk away from their homes, would create? It's a serious problem. Now, you can see in this graph right here how CO2 has risen in the last century. Okay, yeah. Can you see the right side of that graph where the line goes straight up? When I began giving talks on this subject 20 years ago, our atmosphere contained 366 parts per million. I was worried about it. I thought, I told churches that I spoke to, look, 366 is a problem. We don't want to go higher. Well, in 2006, the talk that I gave, I still have the text of it, it was 382. This year, our peak was 420. Okay, now this particular slide is old. It only goes up to 400 parts per million. I don't know what that means to you. Okay, I don't know, how much gripped you are by this, but it shows that over 800,000 years of change on that blue line, the CO2 and with it the temperature that follows, the CO2 varied between 185 and 300. It never really moved out of that, well, didn't move out of that range. And what we've done is we've burned all this fossil fuel and brought carbon up to 420. I think that the thing that lit me up recently was when I looked at this, and of course I've been talking about this graph for a long time, but the difference between the original, the level of CO2 that we developed our civilization in, that was around 275, maybe 300, 315. The difference between that and the last ice age was only 115 parts per million. So it took 115 parts per million of carbon loss, okay, of dropping carbon, to put Berrien Springs under a mile of ice. Right now, what we've done is we've taken that and we've added carbon from that middle point, 135 points above normal. That means basically that we have committed right now. I'm happy the kids aren't here, that they moved out, because that means that we have committed to a hothouse world that is a little unimaginable. It's as radical a departure from normal, from the normal that really I experienced as a child even. It's happening that rapidly, and we're going to get a hothouse Earth that is as radical a departure from normal as the Ice Age was in the other direction. That is frightening. I mean, I can't quite describe what it might mean, because we've never experienced, human beings have never experienced a world like what we're headed into. Now, I don't think many Americans really appreciate how threatening conditions that bizarre vertical line really indicates. In effect, it means that there will never again be something that we can refer to as the old days when it was normal. There won't be any normal anymore, because we'll always be trailing by 20 or 30 years this impossibly rising line of carbon dioxide. It's just going to get hotter. The good news is Berrien Springs is a nice place to live. Even in the projections, Mishawaka and Berrien Springs fare pretty well. That doesn't mean we get out home free, okay? It means that, you know, we may have trouble with water, we may have trouble with famine, we may have trouble. The world is gonna have difficulties, and we're not going to escape just because our days are more pleasant than a lot of days. I wouldn't want to live in southern Florida. Matter of fact, the southern coast of the United States is really going to have problems in the next 60 years. So we know beyond any shadow of a doubt that this is going to happen. It's indisputable. What the early hockey stick in my early talks suggested that global temperatures would rise, and what happens, or what has happened since I started talking, is all 20 of the last 20 years have been the hottest on record. Not quite consecutively, but very close. And in fact, go ahead, Beth. Oh gosh, go ahead and skip that particular slide. 2021 was the warmest year on record. You can see what's happened since I started talking in 2001. It's basically just gone up. And take the next slide. The hottest of all have been the last 7 years. Actually, go ahead, next slide. You can add to that 2021. So it's been the last 8 years have been the hottest. It's not proof, but it comes close to proving the fact that we're following that line straight up. It's just going to get hotter. Earth's temperature's gone up a little, excuse me, I got a hiccup. Earth's temperature has gone up a little bit more than 1 degree centigrade in the last century. But now it's rising so quickly that scientists project that we're going to breach the 1.5 the 1.5 mark perhaps sometime in this decade. That was originally 30 or 40 years ago. That 1.5 degrees was what they imagined would be the worst possible condition that we'd want to pass. We're going to get there. We're going to get there probably, I'm guessing, this decade. And sometime here in this century, we're going to go between 2.7 and 3.9 degrees above that original pre-industrial baseline. Now, this affects our children. The kids that just walked out of the room are going to have much more difficult lives on account of this. And all future generations, the effects that they feel will not be linear. And the reason why is because the carbon molecule that you add today is going to be there 1,000 years from now. All of them are accumulating, and they're all retaining heat. Now, that means that episodes like droughts and punishing 120 and 130 degree heat waves and extreme flooding, all of that stuff is just going to become more commonplace. Now, frankly, I'll tell you something. I've been reading about this for years, and I think the scariest article that I ever read was about extinction. And I frankly don't believe that civilization will hold together much around if we pass about 4 degrees centigrade. The worst case scenarios, we're definitely going to do that in this century, in the century that those kids are going to grow up to be my age. So, this is a problem we have to look at. In fact, this year, a subgroup of the IPCC, that's the International Panel on Climate Change, a subgroup of that panel wrote an essay, a letter that said the IPCC and the UN are not paying sufficient attention to the possibility of utter catastrophe. The group believes that we face a 10% chance of near human extinction somewhere around the end of this century. Boy, that's just, it's a weight on my shoulders. That's why I speak, because I don't have anything else I can do, really. But that's all bad, if that's the bad news, okay, maybe extinction, what could possibly be good? And it seems that a little bit of hope is in order. Go ahead, Beth. And the good news is that the technology to replace carbon fuels is already present, and despite the doubters, it can work. Did you know that last April, 28% of the energy used in the month of April in the US was provided by renewable sources? Okay, who knew? We turn on our light bulbs, and they work. We boil our coffee and they work, and it was renewable energy, at least a quarter of it was. We know that we can get there. And, we've changed already once from wood to coal, and from coal, my basic carrying of ash upstairs from the basement, to gas and oil and electricity. But this time we don't have 60 years to ramp up. We need to build out and almost certainly stop using carbon just in the next, 10 to 20 years. That's hard to imagine. All the cars, first of all the cars on the road, they're all going to be junked in 20 years anyway. Think about it. There are very few cars on the road that are 20 years old. What that means is that right now, today, we need to start buying electric cars. And electric cars, if the energy comes from coal, well, they're not any cleaner than the gas cars. But as renewable sources come online, electric cars become cleaner. Okay, and eventually, when renewables are 100% of our supply or very close, then everything is clean. We've done away with the problem, and in fact, after 2050, they believe that we need to press down, stop our use of carbon, and after 2050, we need to actually start drawing carbon out of the atmosphere. There are ways to do that. It's a technological challenge, but believe me, those challenges, I've looked, and though you don't read as much about about the new technology maybe as you see about the bad things that are happening, but these problems are solvable. That's how startups and new industries and new billionaires get made. We just haven't met the Bill Gates of this next generation. He's going to be there. He's going to turn out, and it's going to be involved in carbon. So no matter what, we are going to make the change, and we're going to make the change because we really don't have any other choice. I'm fairly certain that before long, practically all of human ingenuity is going to be focused on solving this particular problem one way or another. And I have a great deal of confidence that we're going to succeed. Some mornings I get up on the wrong side of the bed, and that's not the case. We're running a tight race. There's no doubt about it. But there's more good news, and that is that repeated surveys show that 2/3 of Americans, somewhere between 66 and 80% of Americans, are in fact actively concerned about climate change. They actively want to do something about it. Less than 35% of the population is not supportive, and only 10% of the population is actively hostile to the idea. Those are the ones who look at me and say, Ron, you're full of crap, okay? And they're hostile about it. They really, but they're only 10%. On the whole, the United, it may be more here in some corners of Michigan, okay, and Indiana, but on the whole, the United States is an outlier in world opinion. The rest of the world is rapidly coming on board and moving toward all in. China's still using coal, but guess what? They're at the same time building out an enormous renewables industry. They know what's coming. Now, the evidence in climate science is absolutely indisputable, and it represents an existential challenge for democracy. And for us here in church, it also is a moral challenge. The question is a moral question. Do we change, or do we shipwreck that next generation? Do we take care of creation, or to avoid the effort, do we conveniently assume that Revelation is playing out and it's all God's fault? Even in Revelation, though, in Revelation 11:18, I was reading it, God specified that there would be a special place in hell, a special wrath for those who have destroyed the earth. In some versions, it's a special wrath for polluters. It's very specific right there in the end of the Bible. So the easy conclusion about Revelation does not make sense to me. If God had wanted this to happen, if God had wanted the next generation to suffer, why would he have given us the tools to prevent it? That makes, we have agency here, and we should be thinking about it. So you have some of those tools personally. Go ahead and the next slide. Never underestimate the value of personal virtue. Now, whether you, I don't know where I put my straw, whether you choose as a daily personal reminder your own impact on, you've got impact on the planet, and whether you remember it by reusing your plastic straws or by buying an electric car, I don't know what you're going to do now, you can remember that personal leadership does make a difference in the world. Right now, it may be the only way you make a difference in the world. Live your life, but make your choices wisely. Next slide, Beth. Use your voice, okay? Second, always stand up for what is right. In conversation, present the evidence as best you can. And I know that that's nearly impossible. You can't say, oh, I've seen a graph and it went way up and so on. You'll get tongue-tied right away. It doesn't work. Sometimes the best that you can do is to say just that you personally believe that this is an urgent problem, that rapid change is necessary. And then build with your friends on what you find is positive. But use your voice. And finally, Beth, use your vote. Okay, in America, big changes usually don't happen without the support of churches and synagogues. The block of Americans who identify with religion can swing almost any vote. All they have to do is get out. Push your representatives to know that moving toward renewable energy is a high priority for you, even in the face of all those other kitchen table issues that we all face. Fossil fuels are the biggest industry on Earth, and reducing their influence is going to require a mass movement that's not unlike what we saw on the first Earth Day. I don't know how many of you participated. When 10% of the entire American population turned out for a single day of protest, the politicians paid attention. That's when we got the EPA, the Clean Water Act, the Clean Air Act, things that America could be proud of. We need more of that. Unless there's pressure, corporations will always do things and dump their waste in the cheapest way possible, because corporations are only metaphors for people. They're legal. They are legal constructs. They don't have grandchildren to worry about. The evidence is that the current course of our corporate America, of our corporate world, will lead to terrible outcomes. Certainly worse than the inconvenience of changing, and definitely worse than any abstract fears that people have of maybe government intervention or of problems with government guidance. Now, I'm supposed to end talks on a note of hope. And in a talk like this one that I just gave, that seems nearly impossible. But this quote, given from a speech by Margaret Marshall, the Chief Justice of the Massachusetts Supreme Court, not long ago back, she said something that works nicely. She said, "None of us can change the entire world, but each of us can change for the better the world that we inhabit. Each of us can live within the truth rather than the lie. We can lean into politics rather than withdraw from it. We can support the institutions that civilize our lives and make democracy possible. And we can speak up for the veracity and decency when veracity and decency when it matters, including challenging people within our own political and cultural tribes, even as we listen well to others. These," she said, "are not heroic requirements, but they are essential ones. Everything hinges on Americans sending forth ripples of hope." So, do you have questions? I'm sorry that I went so long. Jim?
I don't think anyone would not take anyway, let's give a round of applause. And so, Ron, we're going to have a